Okay, so agent AI systems are officially here. We're talking about these teams of AI agents all working on their own to tackle some really complex stuff. But, as these systems get bigger and bigger, a really interesting new problem starts to pop up. And that's what we're going to dive into today. And it's a super important question, right? I mean, think about it. When you've got dozens, maybe even hundreds of these agents all interacting with each other, how in the world do you keep them all up to date? How do you figure out what went wrong when there's an error? How do you keep the cost from going through the roof? And of course, how do you make sure they're all playing by the rules? Trying to manage all that by hand? Yeah, that's just not going to happen.
So here's the solution, and it's kind of brilliant, almost a paradox, really. It turns out the best way to manage these complex AI systems is to build other specialized AIs to do the managing for us. We're going to break down 4 really powerful patterns that show you exactly how this works.
All right, so first we'll kind of set the stage with this whole idea of AI managing other AI. Then we'll get into the specifics with 4 key patterns: how to keep agents up to date, how to understand what they're actually doing, how to keep costs in check, and finally, how to make sure they follow the rulebook. So the big idea here is using what the source material calls ancillary agents. These are basically specialized AIs whose entire job is to support the main agents doing the work. You can think of them as the managers, the accountants, and yeah, even the auditors, but for an all AI workforce. Okay, let's jump into our first big challenge. A lot of these agent systems are working in environments that change constantly. Think about financial markets or e-commerce. Things are always shifting. And here's the problem. An agent's code is static. It's fixed. So when the world changes, that poor agent can become useless, like overnight. And this slide, it perfectly shows the old, totally broken way of doing things. Just imagine, a new competitor's product pops up. Well, Agent A, the one that's supposed to be scanning the market, has no idea what it's even looking for anymore. So naturally, it fails. And that failure, it kicks off this whole painful process where a human developer has to jump in, manually update the code, test everything, and push out a brand new version. It's just so slow, so expensive, and honestly, a total mess. Okay, so the solution here is all about a really smart separation of concerns. The key is to decouple the agent's core logic, the how it does its job, from the information that's always changing, the what it needs to know. This pattern basically pulls all that shifting data out and puts it into a central configuration file or database that the agent can just read from. Now check this out. This is the new way. And what's so cool here is the automation. Instead of a person, we have a supervisory agent. This little guy is constantly watching the data stream. It sees that another agent found a new product, it grabs all the important details, and then, all by itself, it updates that central database. So the next time Agent A runs its task, it just reads the new info from the database and boom, it works perfectly. Zero human intervention, no code changes. It's awesome. All right, let's move on to challenge number 2. See, a single task can set off this really complex chain reaction of different agents talking to each other. And when something breaks somewhere in that chain, well, the whole system can feel like a total black box. You have no idea what went wrong. Exactly. If you don't have a record of what happened step by step, you've got no clue how to fix it or make it better. Was it a network glitch? Did it get some bad data? Or was it just some weird, unexpected interaction between 2 agents? We're flying blind. We absolutely need visibility. So the solution is to use something called an instrumentation library that basically tracks everything. It gives a unique trace ID to the entire task from the very beginning to the very end. And then every single step along the way, every little chat between 2 agents gets logged as a span. What you end up with is this perfect step-by-step map of the whole entire process. And once you have all that amazing data, you bring in another one of our helper agent, the analysis agent. This agent's job is to pore through all that information. It can automatically find performance bottlenecks, pinpoint the exact root cause of an error, and even spot weird or unusual behavior. And this isn't just for fixing bugs. This analysis gives you this incredible data set you can use to retrain your agents, making the whole system smarter and smarter over time. Oh, and that's a bonus. You get a perfect audit trail of everything that happened. Okay, let's talk about a problem that I'm sure anyone building with AI is very familiar with: money, the cost. Using these super powerful large language models can get really expensive really fast. If you're not paying close attention, those costs can just spiral out of control. Yeah, the way they usually bill you is based on tokens. Basically, you pay for every little piece of text you send to the model and every piece you get back. Now, imagine a system with tons of agents having thousands of conversations. Those costs just add up like crazy, and it's super easy to blow right past your budget. And this is where our third helper agent comes in, the FinOps agent. FinOps just stands for Financial Operations, and this agent's whole reason for being is to act as the system's automated accountant. It's always on, always working to keep those cloud and LLM costs as low as possible. And this table shows you its playbook, basically how it saves you money. So for a really simple task, it's smart enough not to use the big expensive model. Instead, it routes the job to a smaller, much cheaper one. It'll also automatically trim down prompts to use fewer tokens. It caches answers to common questions, so you're not paying for the same result over and over again. And it even manages the cloud resources, pushing non-urgent tasks to cheaper, off-peak hours. It's like having a proactive, automated cost control officer working 24/7.
All right, let's get to our final pattern, and this one is all about governance. The big question here is, how do you make sure that every single agent in your system is behaving the way it's supposed to, following company rules and staying compliant with regulations?
And these are just a handful of examples of the kinds of policies we're talking about. For instance, a trading agent absolutely cannot go over a specific trade limit. A warehouse robot that's all about speed has to give way to another one focused on safety. Or an agent helping customers, well, it definitely shouldn't be able to peek at sensitive financial data. These kinds of rules they're non-negotiable. Now, the old way of handling this was a complete nightmare. You'd bury these rules deep inside each agent's code. So what happens when a policy changes? You guessed it. You have to go hunt down every single agent and update it by hand. The solution is so much cleaner. You centralize all of that logic into one single automated policy engine. And here's how it works. It's actually pretty elegant. Before any agent does anything, it first has to ask the policy engine for permission. The engine takes a look at what the agent wants to do and checks it against the central rulebook. Then it can do one of three things: approve it, reject it flat out, or, and this is really cool, it can even tweak the action to make it compliant. This makes sure that every agent is following the rules consistently all the time. So let's do a quick recap of our AI management toolkit. First, we've got the supervisory agent, which keeps the whole system fresh and up to date. Then there's the analysis agent, giving us that crystal clear visibility into what's happening. We have the FinOps agent, our automated accountant watching the budget, and finally, the policy engine, which is like the universal rulebook for everyone. Put them all together and you get a system that's robust, easy to manage, and ready to scale. And that really brings us to a final, pretty mind-bending thought. We've just walked through how we can use AI to build systems that literally manage themselves. They can update their own knowledge, they can debug their own errors, and they can govern their own behavior. That's a huge shift in how we think about building technology. And it really makes you wonder, if AI can manage its own code, its own costs, and its own conduct, what's next?